I'm Julius Dela Cruz, and today we will be tackling the topic of angle modulation. So first and foremost, alamin muna natin ano ba yung modulation. So sa electronics and telecommunications, modulation is the process of varying a periodic waveform which we call the carrier signal by a modulating signal that contains the information to be transmitted. So, sa past lesson, which is yung amplitude modulation, the waveform is modulated by varying the amplitude nung wave. So, anong pinagkaiba ng amplitude modulation sa angle modulation? Ano ba yung angle modulation? Angle modulation is the process in which the frequency or the phase of the carrier varies according to the message signal. So, ang main difference lang naman ng angle modulation sa amplitude modulation is instead na amplitude yung nagva-vary sa tulad ng sa amplitude modulation. Dito naman, ang binabago is yung frequency or yung phase ng carrier. So, ano ba meaning ng frequency at ng phase? So, first is, what is frequency? Frequency is the number of occurrences of repeating event per unit time. It has the unit of hertz, and probably na-encounter na natin to. Madalas natin to na-encounter, lalo na sa circuits 2, which is yung more on AC, di ba? So, sa Pilipinas, ang standard is 220 volts and 60 hertz. So, yung 60 hertz simply means na yung AC cycle or yung AC signal repeats itself 60 times per second. So, dito natin makikita na repeating event per unit time. So, 60 times na maulit yung AC signal sa isang segundo. So, paano ba natin hinahanap yung frequency ng isang waveform? Maraming ways. So, ito yung ilan or ito yung ilan sa ways para mahanap ang frequency ng isang waveform. First is finding frequency of electromagnetic waves in a vacuum. So dito makita natin na to find the frequency, we simply need to divide the speed of light by the wavelength of the waveform. Next is finding frequency from wavelength. Dito naman, ang dinidivide natin is yung velocity ng wave sa wavelength niya. Next naman is finding frequency from time per period. Ito yung madalas sa atin nakikita doon sa AC circuits 2, which para self-explanatory na lang, i-divide mo lang, kukunin mo lang yung inverse ng time period o yung amount of time na kinailangan para makumpleto yung single wave oscillation. And last is the finding frequency from angular frequency. So dito parang self-explanatory naman na i-divide mo lang yung angular frequency sa 2 pi. Next is ano ba yung phase? Phase is the position of a point in time, definition of the position of a point in time on a waveform cycle. It can also be an expression of relative displacement between or among waves having the same frequency. So, kunyari, sa isang AC signal, nag-select tayo ng isang point dun sa waveform na yun, ayun yung phase. Tapos, it's commonly sa degrees, and para dun pumapasok yung lagging, leading, diba? Dun sa circuits 2. It has the unit of radian or degrees, as I've said. So, dako naman tayo sa types of angle modulation. There are 2 main types of angle modulation, which is frequency modulation or FM at phase modulation or PM. So, unahin muna natin yung frequency modulation. Frequency modulation is the process of varying the frequency of the carrier signal linearly with the message signal. So, ang meaning lang na to, parang pag in-increase natin yung amplitude ng modulating signal is matataas yung frequency nung carrier signal. So, it is widely used on frequencies above 30 MHz, and it is particularly well known for its use for very high frequencies or VHF FM broadcasting. So, ano ba yung pros niya? First is resilient to noise, thus able to provide near interference-free reception. easy to apply modulation at a low power stage of the transmitter. So could offer high fidelity audio, and for this reason, FM is far more popular than older transmissions on the long, medium, and shortwave bands. It is also used for a variety of two-way radio communication systems, whether for fixed or mobile radio communication systems or for use in portable applications. So ayun, I think self-explanatory naman itong mga to. And also FM covers all the frequency range which humans can hear. So ano naman yung cons ng FM? At higher frequency, FM modulated signals cannot pass through the ionosphere and do not get reflected. Hence, FM has lesser coverage compared to AM signal. So, mas malawak yung range ng AM signal, pero yung FM naman is more resilient to noise or interference. Sa FM din, mas complicated yung pag-demodulate ng signal or yung pagbasa ng signal. So how does frequency modulation work? As sinabi ko kanina, to generate a frequency modulated signal, the frequency of the radio carrier is changed in line with the amplitude of the incoming audio signal, or kahit hindi audio, basta incoming signal. The carrier frequency, or FC, is the waveform that is to be modulated. The modulating signal FM changes the frequency of the carrier, which changes to its amplitude. The carrier will be at its maximum Fmax when the amplitude of the modulating signal is at its highest, while it will be at its minimum or Fmin when the amplitude of the modulating signal is at its lowest. So dito makita natin sa example. Itong top part, ito yung unmodulated carrier frequency. Itong middle part, ito naman yung modulating signal. So, itong third wave, ito yung yung modulated carrier na. So, mapapansin nyo na sa part na to, which is yung peak amplitude ng modulating frequency or modulating signal, yung frequency ng carrier is at its highest din. So, ayun yung tinatawag nating Fmax. So, dito makikita natin, di ba? Dito naman, sa parang sa trough or yung, tama ba? Basta yung pinaka lowest amplitude ng modulating signal, ayun naman yung Fmin. Tapos, kung makikita natin dito sa waveform, yung frequency din niya is yung pinakamaliit. So, tinatawag natin siyang Fmin. So, ano ba yung frequency deviation? Yung frequency deviation is the amount of change in the carrier frequency produced by the amplitude of the input modulating signal. So, it basically means kung gaano na bago ng modulating signal yung carrier frequency. It is denoted by delta F, and it can be found by finding the difference between the carrier frequency or FC and the minimum modulated frequency or FC min. Therefore, delta F is equals to FC minus F min. Pwede rin siyang mahanap by finding the difference between the maximum modulated frequency or Fmax and the carrier frequency. Therefore, delta F is equals to Fmax minus FC. So, in short, delta F is equals to Fmax minus FC, and is equals to FC minus Fmin. It can also be found by finding the product of the modulator's deviation sensitivity constant and the modulating signal's maximum voltage. Therefore, it can be expressed as delta F is equals to Kf times Vn. Yung deviation sensitivity constant is yung constant yan sa frequency modulator na ginagamit natin. It's usually given or found pagka given yung other parameters or yung other variables. So, carrier swing is the total variation in the frequency of the carrier from the lowest to highest point. So, yung frequency deviation kasi is yung peak variation ng frequency carrier. pero yung carrier swing naman, siya naman yung peak-to-peak deviation in frequency. So, ayun, pwede natin siya express as 2 delta F, and pwede rin siyang mahanap by subtracting the minimum modulated frequency from the maximum modulating frequency. So 2 delta F is equals to F max minus F min. So here's an example. A 200 MHz carrier is frequency modulated by a 10 volt peak-to-peak signal of 10 kHz. The instantaneous carrier frequency varies between 199.9 MHz and 200.10 MHz. So what is the frequency deviation? So ang given is carrier frequency of 200 MHz, modulating frequency of 10 kHz, the modulating amplitude of 10 volts, a maximum modulated frequency of 200.1 MHz, at minimum modulated frequency of 199.9 MHz. Ang hinahanap natin is yung frequency deviation. So, since frequency deviation ang hinahanap natin, hindi lahat ng given is magagamit. So, ang gagamitin lang natin dito is yung FC, Fmax, and Fmin. And dalawang solution yung pwede natin gamitin, which is yung delta F is equal to Fmax minus Fc, at yung delta F is equal to Fc minus Fmin. So, finding it like this, yun. Pagka sinubtract natin yung 200 MHz sa 200.1 MHz, that yields us 100 kHz, which is yung deviation, frequency deviation. So, pag ginamit naman natin yung isa pang formula by subtracting 199.9 MHz from 200 MHz, same lang 100 kHz. So, it checks out yung formula natin na delta F is equals to F max minus Fc and equals to Fc minus Fmin. Another problem. So, a 200 MHz carrier is frequency modulated by 10 volt peak-to-peak signal of 10 kHz. The instantaneous carrier frequency varies between 199.9 and 200.1 MHz. What is the carrier frequency if the frequency deviation is 100 kHz? Carrier swing pala. So, same lang yung given, pero this time, binigay na rin sa atin yung frequency deviation. At ang hinahanap natin is yung carrier swing or yung peak-to-peak frequency deviation. So, pwede natin siyang mahanap gamit ang dalawang formula lang to, which is yung 2 delta F or F max minus F min. So, simply multiplying the frequency deviation by 2 yields us a carrier swing of 200 kHz. Pag ginamit naman natin yung isang formula by subtracting 200.1 MHz by 199.9 MHz, we get the same 200 kHz carrier swing. So ito naman, another example. A 200 MHz carrier is frequency modulated by a 10 volt peak-to-peak signal of 10 kHz. The instantaneous carrier frequency varies between 199.9 and 200.1 MHz. What is the deviation sensitivity of the frequency modulator if the frequency deviation is 10 kHz? Ngayon, ang hinahanap naman natin is deviation sensitivity. Same lang yung given as last time. So, pero, ang gagamitin lang natin dito is yung modulating voltage yun at yung frequency deviation. Ang hinahanap natin is deviation sensitivity. So, given this formula of delta F is equals to Kf times Vm, pwede nating mahanap yung Kf by dividing both sides by Vm. So, yun, Kf is equals to delta F over Vm, and substituting gives us Kf of 100 kHz divided by 10 volts. That yields us a deviation sensitivity of 10 kHz per volt. So, ayun madalas yung unit ng deviation sensitivity, kilohertz per volt. Remember that. Let's proceed to the FM modulation index. The FM modulation index is the ratio of the frequency deviation of the carrier to the frequency of the modulating signal. So, ito yung ratio kung gaano nabago yung frequency ng carrier doon sa frequency nung nag-modulate na signal. It is denoted by MF and Since ratio nga siya ng frequency deviation at ng frequency ng modulating frequency, it can be denoted by the following equation, which is MF is equals to delta F over FM. At delta F refers to the peak frequency shift to carrier, since carrier swing nga yung peak to peak frequency shift. Here's an example. A 200 MHz carrier is frequency modulated by a 10 volt peak to peak signal of 10 kHz. The instantaneous carrier frequency varies between 199.9 and 200.1 MHz. What is the modulation index if the frequency deviation is 10 kHz and the frequency modulator sensitivity is 10 kHz per volt? So, ang hinahanap natin dito is modulation index. At ang given is, we were given the carrier frequency, the modulating frequency, the modulating voltage, the maximum modulated frequency, the minimum modulated frequency, the frequency deviation, and the deviation sensitivity. Pero since ang hinahanap natin dito is yung modulation index, ang kailangan lang natin is yung deviation sensitivity at yung modulating frequency, or yung deviation sensitivity, yung modulating voltage at yung modulating frequency. So, pag tinignan natin itong pangalawang formula, we can notice na yung KF times VM is a formula for finding delta F. So, essentially, parehas lang sila. So, pwede mo gamitin itong pangalawang formula if hindi given yung frequency deviation. Since ito yung formula sa paghanap sa frequency deviation. So, using the first formula, we divide 100 kHz by the modulating frequency of 10 kHz, and that gives us a modulation index of 10. So, ang modulation index is unitless. So, using the other formula, 10 kHz multiply by 10 volts divided by 10 kHz. So, pag multiply natin itong dalawa, makakancel yung volts. So, we are left with 100 kHz divided by 10 kHz. And that gives us a modulation index of 10. So, pares lang sila. So, let's proceed to percent modulation. Percent modulation is the ratio of the frequency deviation actually produced to the maximum frequency deviation allowed. It is mathematically stated as M is equals to delta F actual or over delta F max times 100. Pwedeng M is percent modulation, so pwede rin percent modulation yung denotion. So, ano naman yung deviation ratio? Deviation ratio is the modulation index of the maximum allowable frequency deviation and the maximum modulating frequency. It is also the worst case modulation index because it produces the widest output frequency spectrum. So, pag dumana tayo mamaya sa frequency analysis of angle modulated waves, makita natin na habang lumalaki ang modulation index, the more side frequencies it will produce. So, kaya siya naging worst case modulation index dahil the more side frequencies produced, the more na i-spread out yung distribution ng power. So, hindi siya nagiging efficient. So, here's an example. In the United States, the Federal Communications Commission or FCC limits the frequency deviation for commercial FM broadcast band transmitters to plus minus 75 kHz. If a modulating signal produces plus minus 50 kHz frequency deviation, the percent modulation is, so ang given natin is yung delta, yung maximum allowed deviation, frequency deviation, which is yung plus minus 75 kHz, at yung actual na frequency deviation na na-produce, which is yung plus minus 50 kHz. Ang required is yung percent modulation, so we use this following formula, which is delta F actual divided by delta F max times 100. So 50 kHz divided by 75 kHz gives us 0.66667. Multiply that by 100 and we get a percent modulation of 66.667%. So another example is a 200 MHz carrier is frequency modulated by a 10 volt peak to peak signal of 7.5 kHz. In the United States, the Federal Communications Commission or FCC limits the frequency deviation for commercial FM broadcast band transmitters to plus minus 75 kHz. So what is the deviation ratio of the frequency modulator? So same lang ang given, pero this time we have a modulating voltage and a frequency, carrier frequency at modulating frequency. Tapos ang hinahanap naman natin is yung deviation ratio. So remember, ang deviation ratio is just the modulation index of the maximum allowed frequency deviation. So pwede natin siyang mahanap by using the modulation index formula of delta F over Fm, pero this time ang gagamitin natin delta F is yung delta F max or yung maximum allowed frequency deviation. So using this, 75 kHz na maximum allowed frequency deviation is divided by 7.5 kHz na modulating frequency, which yields us a deviation ratio of 10. So modulation index yan na 10. So let's proceed to the frequency analysis of angle modulated waves. Bessel functions. Bessel functions are used to find the number of sideband pairs produced by a modulation index. So, as I said kanina, the higher the modulation index, the more side frequencies it produces. At ginagamit natin yung Bessel functions or in this case yung Bessel table para mahanap kung ilan side frequencies na produce ng isang modulation index, as well as yung ratio ng amplitude between the carrier and the side frequencies. So as we can see here, ito yung modulation index, tapos ito yung number of frequencies produced by the said modulation index, tapos itong mga values na to, ito yung ratio ng carrier amplitude sa side frequencies amplitude. So frequency spectrum is a plot of a signal with respect to frequency. It shows the relative amplitude of sideband pairs. So, it's a plot. Plot ano siya ng frequency, tapos nakalagay doon kung ano yung relative amplitudes ng sideband pairs pati ng carrier frequency. The relative amplitude of sideband is the absolute value of the product of the ratio of side frequencies amplitude and the carrier amplitude Jn. So sila yung values na to. Ayun yung Jn. It's given by the Bessel function and the carrier amplitude. Therefore, it can be expressed with the following formula, which is Vn is equals to absolute value of Jn times Vc, where Vn is the sideband amplitude, Jn is the ratio of side frequencies amplitude and the carrier amplitude, and Vc, which is the carrier amplitude. Here, ito yung example ng isang frequency spectrum. Sa vertical plane, kita natin, ito yung amplitude. So, ngayon say na 0.51 volts, 0.56 volts, 0.33 volts, 0.6 volts, 0.1 volts. At mapapansin natin na by pair sila. By pair sidebands na naproproduce. Isa sa lower and isa sa higher. For an FM modulator with ito example. For an FM modulator with the modulation index of 1, a modulating signal with a 2 volt peak-to-peak amplitude, and a non-modulated carrier with a 10 volt peak-to-peak amplitude, what will the frequency spectrum look like if the carrier frequency is 500 kHz and a frequency deviation of plus minus 1 kHz? So ang given natin is modulation index, a modulating voltage, and a carrier voltage or carrier amplitude of 10 volts. So ang hinahanap is ang frequency spectrum. So pag chinek natin yung Bessel table, a modulation index of 1 modulation index of 1 yields 3 sideband amplitudes, tapos andito yung carrier. Ito yung sideband amplitudes, ito yung carrier. So 3. In the Bessel table, a modulation index of 1 yields 3 sideband pairs with the following ratio side frequencies amplitude or carrier amplitude. Yung J0, siya yung carrier, yung modulated carrier amplitude. Yung ratio niya pagka na-modulate na. J1 is yung first set of sidebands, J2 second set, J3 third set. So in solution, gagamitin lang natin yung formula which is Vn is equals to absolute value of Jn times Vc. So yung V0 which is yung modulated carrier amplitude will be 7.7 volts. Yung V1 naman or yung first set of sideband amplitudes will have 4.4 volts. V2 1.1 volts, V3 will be 0.2 volts. Tapos ito yung magiging plot niya. So we can see here 7.7 volts yung modulated carrier. First set of sidebands is 4.4 volts. Second set, 1.1 volts, 0.2 volts. And as you can see, yung carrier frequency na 500 kHz ay may frequency deviation plus 1 kHz plus or minus 1 kHz. So dito sa horizontal plane, every sideband will have a frequency that is FC plus kung ano man yung frequency deviation niya. Frequency modulation bandwidth. A bandwidth is the difference between the upper and lower side frequencies in a continuous band of frequencies. In FM, the bandwidth can be approximated using Carson's rule, which states that all significant sideband energy, or 98% or more, is concentrated within the bandwidth. Carson's rule can be expressed with the expression bandwidth is equals to 2 times delta F plus Fm, where BW is bandwidth, delta F is frequency deviation, and Fm is the modulation frequency. Or bandwidth is equals to 2 times the product of the sum of the product of M times Fm plus Fm, where BW is bandwidth, M is modulating index, and FM is modulating frequency. So magkaiba yung actual bandwidth sa bandwidth pag using Carson's rule. Kasi Carson's rule is just an approximation of the bandwidth. The actual bandwidth can be found by the following expression, which bandwidth is equal to 2 times n plus 2 times n times Fm, where BW is bandwidth, N is the number of significant sidebands from the Bessel function, and Fm is the modulating frequency. So madalas gagamitin natin yung actual bandwidth pag alam natin yung modulating index nung wave. Pero pagka nandun lang din siya sa Bessel table. So yun. Here's an example. A music signal carrier is with a modulating frequency of 21 kHz. If the frequency deviation is 50 kHz, what is the modulation index and the signal's bandwidth using Carson's rule? So ang given natin is a modulating frequency of 21 kHz and a frequency deviation of 50 kHz. Ay nahanap natin is yung modulation index na at yung bandwidth. So using the following equation of MF is equals to delta F over Fm, we can find the modulation index. So 50 kHz divided by 21 kHz gives us a modulation index of 2.381. Thus, using Carson's rule, we can find the bandwidth by multiplying the sum of the frequency deviation and modulating frequency by 2. So substituting the values, we get 2 times 50 kHz plus 21 kHz, then 2 times 71 kHz, which yields us a bandwidth of 142 kHz. Another example. A music signal carrier is with a modulating frequency of 10 kHz. If the frequency deviation is 10 kHz, What is the modulation index and the signal's actual bandwidth? The given is a modulating frequency of 10 kHz and a deviation frequency of 10 kHz. Tapos, ang hinahanap is modulation index at yung actual bandwidth. So, una, hanapin muna natin yung modulation index. Modulation index is 1. We found that by dividing the frequency deviation with the modulating frequency. So, since alam naman natin na ang modulation index sa 1 ay nag-yield ng 3 side frequencies, ang n natin na gagamitin sa formula is 3. So, to find the actual bandwidth, we use the formula BW is equals to 2 times n times Fm, where n is equals to the number of significant side frequency pairs. So, the bandwidth will be 3 times 10, which will be 30 kilohertz times 2 will be 60 kilohertz. So, the bandwidth is 60 kilohertz. So, dako naman tayo sa frequency modulation power distribution. The total power in a frequency modulated wave is equal to the power of the unmodulated carrier. So, this simply means na yung power ng modulated wave is equals to the power ng unmodulated carrier. So, and the average power to unmodulated carrier can be expressed by the following equation, which means PC is equals to VC squared over 2R, where PC is the carrier power, VC is the peak unmodulated carrier voltage, and R is the load resistance. Yung total power can also be expressed by the following expression, which is total power is equals to P0 plus P1 plus P2, so on and so forth, where PT is total power, P0 is the modulated carrier power, P1 is the power in the first set of sidebands, P2 in the power set of second set of sidebands, and Pn is the power of the end set of sidebands. So much like the previous formula, this formula is essentially the same, pero gagamitin natin tong formula to pag hindi given yung power nung ang given naman, ang gagamitin natin to pag ang given is yung amplitude ng sidebands. And etong pangatlo naman natin formula is like this formula, pero pag ang given lang is yung carrier voltage at yung ratio ng carrier and sideband amplitudes according to the Bessel function. So parang parehas lang din sila, pero ang given dito is yung J0, J1, J2, best na yung V1, V2 na rekta na. And last but not the least is this. Total power is equals to the PC times J0 squared plus 2 times J1 squared plus J2 squared plus J squared, where PC is carrier power and the J values are represented of the respective values based on the Bessel function. So, let's take an example. For an FM modulator with a modulation index of 1, a modulating signal with a 2-volt peak-to-peak amplitude, and a modulated carrier power with a 10-volt peak-to-peak amplitude, what is the unmodulated carrier power for the FM modulator assuming a load resistance of 50 ohms? The given is the carrier voltage of 10 volts, the modulating voltage of 2 volts, the modulation index of 1, and the load resistance of 50 ohms. At ang hinahanap natin is yung unmodulated carrier power. So the unmodulated carrier power is found by dividing the square of carrier voltage by 2 times the load resistance. So 10 volts squared divided by 2 times 50 ohms yields us 100 volts divided by 100 ohms, which equals to 1 watt. So the total power or the unmodulated carrier power is 1 watt. So the same problem, pero gamit naman tayo ng ibang formula. So, ang hinahanap pa rin natin dito is yung unmodulated carrier power or yung total power. So, sa Bessel table, alam natin na 1 yields 3 sideband pairs, tapos ito yung kanilang relative ratios of side frequencies to amplitude. Side frequency amplitude and carrier amplitude. So, J0 or the modulated carrier ratio 1.77, the first set of sideband 0.44, second set 0.11, third set 0.02. So ang gagamitin nating formula is ito. So substituting the values, we get this and itong first power, ito yung modulated carrier power. Ito yung power ng first set of sideband, power second set of sideband, power third set of sidebands. And adding them together, we get 1.0051 watts. So essentially, para halos pares din sila, almost equal sila ng first formula, pero this time mas accurate gamitin itong formula ito. So let's proceed with the second type of angle modulation, which is phase modulation. Phase modulation is a process in which the phase of the carrier wave is changed according to the amplitude of the modulating signal. So, tulad lang ng frequency modulation, hindi amplitude ang binabago, but instead it is the phase of the carrier frequency that is changed by varying the amplitude of the modulating signal. It is useful in radio waves transmission, and it is an essential element in several digital transmission coding schemes. It's also widely used for transmitting radio waves and is an integral element of many digital transmission coding schemes that support an ample range of wireless technologies such as GSM, satellite television, and wireless fidelity or Wi-Fi. It's also used in digital synthesizers for generating waveform and signal. So ano yung pros? Pros is yung phase modulation is simple compared to frequency modulation. I doubt that, pero yes, ayun yung apparently as ang pros niya. The main benefit of this modulation is signal modulation, because it permits computer for communicating on high speed using telephone system. Tapos another one is the information is being transmitted without intrusion, then the speed rates can be observed. Also, like FM, it has an improved immunity towards noise. So parehas na yung frequency modulation at yung phase modulation is lamang sa amplitude modulation, in a sense na mas immune sila sa interference and noise. So cons is phase modulation needs two signals with phase variation among them. Through this, both patterns are required to have a reference as well as a signal. This type of modulation requires hardware which are more complex due to its conversion technique. So how does phase modulation work? So phase modulation works by the carrier signal's phase is modulated to follow the amplitude of the modulating signal. Both the peak amplitude and the carrier signal's frequency is maintained stable, but carrier signal's phase changes with respect to changes in the modulating signal's amplitude. So like FM, sa FM, when you change the amplitude of the modulating signal, yung frequency yung nagbabago, pero yung peak amplitude ng carrier frequency is hindi nagbabago, and yung as well as yung phase. Pero this time, ang nagbabago is yung phase, at ang nananatiling constant is yung frequency as well as yung amplitude, peak amplitude. We can see here, dito sa T1 or time 1, nagkaroon tayo ng increase in amplitude ng modulating signal. And as you can see here in the modulated waveform, nagkaroon ng change in phase. Ng phase change dun sa modulating signal. as well as sa T2 and sa T3 at T4 and T5. So makita natin dito na varying the amplitude of the modulating signal yields a change in the phase of the modulated waveform. So phase deviation. Phase deviation is the peak difference between the instantaneous angle of modulated wave and the angle of the sine wave carrier. So kung yung frequency deviation is the change in frequency, the total change in frequency of the carrier to the modulated waveform, ito naman is yung difference ng instantaneous angle ng modulated wave at ng angle ng sine wave carrier. It is expressed by the following formula, which is theta of t is equals to m cosine the angular momentum of the modulating phase t. Thus, where delta t is equals to instantaneous phase deviation, and wmt is equals to instantaneous modulating phase, and the m is the modulation index. The PM modulation index, it is the peak phase deviation. It is proportional to the amplitude of the modulating signal independent of its frequency. It is expressed with the following formula, which is M is equals to KVM, where M is the modulation index, K is the deviation sensitivity, and VM is the peak modulating signal amplitude. So here's an example. Given a phase modulator with a deviation sensitivity of 0.75 rads per volt and the modulating signal of amplitude of 2 volts modulating a carrier frequency of 500 kHz, what would be the modulation index of the modulator? Daming modulation. The given is yung deviation sensitivity ng phase modulator, which is 0.75 rads per volt, the modulating voltage of 2, and the carrier frequency of 500 kHz. Tapos ang hinahanap natin is yung modulation index. So ang formula is MP is equals to KPVM, and substituting, we got 0.75 rad per volt divide times 2 volts. So pag multiply natin sila, maka-cancel yung 2 volts na matitira tayo sa 1.5 radians. Or 1.5. So that is all for angle modulation. I hope you learned something from this discussion, and you can check the following sites and the following references for further clarifications and for further reading and back So ayun, thank you for listening.
We'll be right back.